Okay guys, so we're going to explore today vectors that are parallel, collinear, and we're going to associate with that dividing vectors into a ratio and what a unit vector is. So that's for us to play with. Let's have a look. V can be our first vector. That's always a good letter for a vector. How about 414? Why not? Let's have W as a vector. This one not quite so random. We're going to have 1 and then 3.5. And then X, let's have something like 3, 9 for X. Okay, so we've got three vectors to play with. Now, there's something very interesting about V and W. It is this. In fact, V is 4W. Check it out, guys. Right, okay. 4 times going right 1 is go right 4. 4 times 3.5 is 14. Okay, so V is 4W. Basically what happens if you do this 4 times in a row, then that's the same as doing this. Now what does that mean? That means that this W is going right 1 and up 3.5, so it's something kind of like that. 4 of those, do another one, another one, another one. That whole thing together, that we could call V. Okay, so you could say that V and W are parallel. They go in the same direction. They point in the same direction. They're not the same vector. V is like literally 4 times as long, but they are parallel. They go in the same direction. So parallel means the same as it always did. And vectors will be parallel if and only if they can be written as a multiple of each other. So one of them is something times the other. Okay? So we could explore that slightly further. Let's look and see whether we think V and X are parallel. So we've got V and we've got X. Okay, so to get 4 to turn into 3, I'm going to have to divide by 4 to get the number 1, and then times by 3 to get the number 3. So if I write V, what I'm going to work out is actually 3/4 of V, that's V, divided by 4 times 3. Okay, so let's have a look. V divided by 4 is going to be, let's write it as 3 times. So V divided by 4 is going to be 1. V divided 14 divided by 4, that's going to be 3.5. Oh yes, we knew this because this is W, right? Is 1/4 of V. Now 3 times W, or 3 times 1/4 of V, is 3 times 1 at the top, which is 3. 3 times 3.5 at the bottom, which is going to be 10.5. Why have I done that? Well, you can see the 3 matches vector X, but the instruction here, go up 9 and go up 10.5, is different. These cannot be parallel. They both go right 3, but they go up a different amount. So we could write a little sentence. It's important to do this whenever you're trying to show something or conclude something. So I could say, because 3/4 of V and X both have 3 in first component. This is the component form. That's the first component, that's the second component. But are different in second component. V and W are not parallel. Let me read that out because my writing is terrible. So because 3/4 of V and X, they both have a 3 in the first component. They've both got a 3 there and a 3 there. But they're different in the second component. So that's got a 9 there and a 10.5 there. That means that V and W are not parallel. Sorry, V and X are not parallel. Neither is W, but anyway. Okay, so that's parallel. What you're going to do, you're going to try and make them be the same by multiplying and dividing by something, just like normally with ratios. If it works, they're parallel. If it doesn't work, they are not parallel. Okay? Great. What do we mean by collinear? Well, linear is on a line. Co is sharing, like co-pilot. So collinear is sharing the line they're on the same line. For example, let's suppose I have a vector from A to B, which is going to be 4, 14. And a vector from B to C, which is going to be 1, 3.5. What can I say? I can say that AB and BC are collinear. They lie on the same line. Why is this? 2 points. Remember, we always have to write a sentence to explain ourselves. So it's because, what should we say? Because AB is 4 times BC. So what does that mean? So AB and BC are parallel, and AB and BC also share point B. Okay, so if I've got 2 bits of line, they both go to B here and they both go in the same direction, then they are on the same long straight line. Okay, 2 bits of line that both go through the same point and go in the same direction, they are parallel, they are collinear, they are on the same line. Great, that's collinear, on the same line. It means parallel and share a point. Write that down. Okay, dividing into a ratio. So that's something I could then talk about here. I could say, what, let's do this so you can see it. I could think about that here. What ratio does B divide the line AC into? So we already established that A to B, B to C, are all on a straight line. Okay, what ratio does B divide the line into? Is it halfway? Is it 50-50? Is it somewhere else? Well, AB is 4 times BC. So say if that's a 4, that's a 1. 4 times as big. Okay, so what I could say is that B divides AC into the ratio 4 to 1. Okay, because, get this the right order, A to B is 4. B to C is 1, so from the line AC in that direction, A to C, it's ratio 4 to 1 on A to C. Okay, that's the idea there. We'll just do an example of like how a question can look with that, because they can do it backwards to you. Okay, so let's just come up with a random new question. Let's have D to F. You'll see why in a minute. D to F is going to be, let's say, 6 and minus 9, so it works out nicely. And let's say that the point E divides the line DF into the ratio, let's do 1 to 2. So E is another point, it's on the line DF, it divides it in the ratio 1 to 2. So I don't know, maybe D is here, maybe F is here. Let's just be precise, I don't know. Let's say that D is at minus 1, 4, okay. F we can work out then. So you have to go right 6 and down 9. So it's going to be at 5 and then down 9, 5 minus 5. Okay, so here's DF. E is on that line. It divides in the ratio 1 to 2. So remember, from D to F, 1 to 2. So it's kind of here, right? That's 1, that's 2. Okay, these aren't the actual lengths, it's the ratio of the lengths. Okay, that's probably like root something and that's root something else. But the ratio is 1 to 2. That's twice the size of that. Okay, so how can I work out where E is? Well, we can look at this whole thing here. Okay, I need to divide it in the ratio 1 to 2. So what I always do when I have a ratio, so I get my ratio 1 to 2, and I always work out the total, which is 3. Now what I want to do is have the total length of 6 minus 9, being D to F is the total line, is D to F the whole way, and that's apparently 6 minus 9. So if my total was going to be 3 for this ratio, how do I get to that? I times by 2 on the top and I times by minus 3 on the bottom. So 2 times 2 on the top is 4. 2 times minus 3 on the bottom is minus 6. What have I done? Whatever I did to the total length, I'm doing the same to each part of that length here. Same as how you did ratios back when you were doing ratios. 1 times 2 is 2 on the top. 1 times minus 3 is minus 3 on the bottom. And what have we got, guys? 1 plus 2 makes 3. 2 plus 4 makes 6. Minus 3 plus minus 6 makes minus 9. So to divide a line in a ratio, same as dividing anything else in a ratio, all you do, work out the total, fill in the total line, the whole line, and then figure out whatever you did here, multiplying and dividing, okay? You multiply and divide by the same thing everywhere, and you're using the ratio then to work out what each bit of the line is. So, the first bit of the line, this is going to be D to E, this is going to be E to F, and this here is going to be the whole line from D to F, the total line D to F. So basically from D to E is 2 minus 3. Now D was this point here at 1, 4. Okay? So what I'm going to do is start at, minus 1, 4. So start at minus 1, 4. Add on from D to E, which is going to be 2 and then minus 3. And what's that going to give me for the position of E? Is going to be minus 1, go right 2, and I get to 1. 4, down 3, and I get to 1. There you go, that's fun. E is at 1, 1. Is there anything else related to this we need to do? Well, yes, actually, I'm afraid there is. Okay, let's just use little d to mean the vector minus 1, 4. That's how I would get to the position of D from the origin. Okay, so what am I going to do? What's this last question? I told you I'd tell you about unit vectors. So a question might ask you to find a unit vector in the direction of D. Now, what is a unit vector? A unit vector is a vector which has length equals 1. It has magnitude 1. So what I'm going to do first of all is I'm going to work out the magnitude of D at the moment, which is going to be the square root of minus 1 squared plus 4 squared. That's how long this line is, which is going to be the square root of 1 plus 16, which is the root of 17. Lovely number. Okay, so the current length of D is root 17. Here's a clever idea. What if I write D divided by its length? This is generally how you can work out a unit vector. That's going to be minus 1, 4, and I'm going to be dividing that, 1 over fraction, dividing that by root 17. 1 root 17th of that, which you could, if you want to expand, it would be minus 1 over root 17, and then 4 over root 17 is a vector. So vector go left by 1 over root 17, go up by 4 over root 17. This vector, I guarantee you, is going to have length 1, and it's clearly parallel with D. It's clearly the same direction as D, because it's literally just D multiplied by a number. Okay? If you want to just check what is the modulus of this, well, I would do square root of, okay, minus 1 over root 17. This is where it's fun to practice your surds and your laws of indices. Plus 4 over root 17, square rooted. What's that? Well, here I'm going to have minus 1 squared, which is 1, over root 17 squared, which is 17, plus here, squared. 4 squared is 16, over root 17 squared, which is 17. 1 plus 16 is 17 over 17, which is 1. So here we have a really cool thing, okay? This beautiful vector here, okay? You could write it like that or like that. This beautiful vector here is a vector with length 1 that is parallel to, goes the same direction as D. Okay? That is what we hope to do today.